Welcome, everyone, and thank you for joining us. We have a really exciting session today. We're going to explore how AI-driven entity resolution is transforming AML and KYC, especially for organizations and financial institutions dealing with fragmented data, rising fraud complexity, and growing regulatory pressure. Our goal today isn't just to explain the technology, it's to show how organizations are achieving real, measurable outcomes at scale. And you'll see how AI and graph analytics, they work together to help institutions truly know every customer, reduce false positives, and strengthen compliance with full explainability. So let's dive in. So again, my name is Sebastian Mansell. I'm Senior Director of Product here at TigerGraph. And I work closely with banks, fintechs, and global enterprises that are modernizing their AML and KYC systems, especially where performance, accuracy, and explainability are absolutely critical. In today's session, we'll start with why entity resolution matters, what it is, why it's so difficult to get right, and what happens when it fails. Then we'll move into how it works, looking at the evolution from traditional and rule-based systems to graph-powered and AI-driven approaches. And from there, we'll explore real-world outcomes, showing how organizations are improving compliance, reducing fraud, and accelerating onboarding. And finally, we'll close with a demo that brings it all together. So before we dive into the technology, let's take a step back and look at the problem we're trying to solve. So at the heart of the challenge is data fragmentation, and that's where most AML and KYC processes start to break down. On the left-hand side, you can see what many organizations are struggling with today. Partial KYC data, where profiles are missing key details, device-only identities, where transactions are tied to a device but not verified as an individual, and duplicate data where the same person appears under slightly different names or formats across multiple systems. Now, these inconsistencies make it nearly impossible to get a single trustworthy view of a customer, and that's where risks hide. Next, in the center of the flow, we have the entity resolution engine, and this is the game changer. It connects fragmented records into a single explainable entity, one that updates continuously as new data comes in. And it does this through explainable AI scoring, real-time KYC refresh, and continuous screening for emerging risks. And on the right-hand side, we see the payoff, a unified entity that brings together every relationship across devices, accounts, IPs, merchants, and locations. Now, this unified view is what drives high precision, fewer false positive, and full lineage. And that's exactly what regulators expect today. But the real challenge isn't just fragmented data, it's the legacy tools behind it. And those tools weren't built for real-time connected insights. So most banks still operate with data scattered across business units, multiple systems, and outdated platforms that don't connect. Now, that fragmentation creates blind spots, and with them come hidden risks, higher costs, and slower customer journeys. So let's start with hidden fraud networks. Fraudsters rarely act alone. They use layered identities and mule accounts across organizations. And rule-based systems only see isolated records. They can't connect the dots between people, devices, and behaviors. And as a result, networks stay hidden. Now, when data lives in silos, institutions miss red flags, and that drives fines, enforcement actions, and costly remediation. And this also increases the operational risk and damage credibility with regulators. And that's where the compliance failure comes in. Analysts are also flooded with alerts that go nowhere. There's a high level of false positive, while real risk actually sips through. And this noise overwhelms teams, it drives up cost and delays SAR processing. Now, finally, high friction onboarding. Even legitimate customers get stuck in reviews because their data doesn't align across systems. That means slower onboarding, more drop-offs, and lost business to faster competitors. So, we've seen how legacy systems create blind spots. But why now? Why is 2025 the moment for organizations to modernize AML and KYC with AI-driven entity resolution? Well, for one, we're seeing a massive growth in digital onboarding. There's absolutely an explosion of digital account openings with over 330 million new bank accounts that are projected to be opened online in 2025. That's nearly double the volume from just a few years ago. Customers now expect instant, frictionless onboarding. If you can't verify them in real time, they'll move to a competitor who can. And that creates enormous pressure on compliance teams to maintain both speed and accuracy at scale. And fraud is evolving. Fraudsters have evolved. They no longer act through a single account. They chain transactions across multiple accounts, devices, and identities to mask their behavior. And traditional linear models just can't keep up. Graph AI improves detection, on the other hand, by 50%. So the detection accuracy improves by 50%. And regulators are just not looking for period reviews anymore. They're pushing for continuous real-time KYC and monitoring. Global RegTech spend is expected to exceed $22 billion in 2025, growing at more than 23% annually. And around 85% of organizations are already piloting or implementing continuous KYC frameworks. The expectation is that compliance must be proactive and not reactive. And then there's the rise of generative AI. That's created a new frontier for fraud: synthetic IDs, deepfakes, and AI-generated documents. Synthetic identity fraud alone caused $35 billion in losses in 2023, and deepfake-driven fraud has surged over 1,000% year over year. So financial institutions need AI that can fight AI. So the need for change is clear. Data is exploding, fraud is evolving, and regulators are raising the bar. And when done right, entity resolution delivers measurable impact. It strengthens the three core pillars of compliance and trust: KYC, fraud, and AML, driving both operational efficiency and customer confidence. So let's start with KYC. Accurate entity resolution improves both compliance and customer experience, helping organizations retain up to 25% more customers and deliver the kind of personalization that 80% of people now expect. For fraud detection, unifying identities reduces losses by as much as 45%. And with the digital ID verification market nearing $40 billion, it's clear that this capability is becoming mission critical. And for AML, with an estimated $2 trillion of laundered money annually and $270 billion spent to fight it, legacy systems just can't keep up. So across KYC, fraud, and AML, AI-driven entity resolution isn't just about accuracy. It's about efficiency, it's about trust, and staying ahead of both fraudsters and regulators. But what happens when organizations can't connect those dots? Let's look at a real-world example of what failure looks like at scale. So we're going to take one example here, one striking example, which is the case of Danske Bank. Between 2007 and 2015, Danske Bank laundered more than $800 billion through its Estonian branch. And the fallout was enormous. In 2022, the US Department of Justice imposed a $2 billion fine, the largest AML penalty in Europe at the time. But the fine was only part of the story. The bank's stock value was cut in half, and the reputational damage lasted for years. Trust was broken, both with regulators, customers, and even investors. And this wasn't an isolated case. Just last year, the DOJ fined another major bank $3 billion for similar AML failures. So the question becomes, why do traditional methods for entity resolution, why do they keep failing, right? And the answer lies in how entity resolution itself is done. Let's take a look at three main approaches: deterministic, probabilistic, and AI-driven. And we're going to see how graph technology enhances each of them. So graph enhanced deterministic approach. Deterministic matching is rule-based. It's name to name, address to address. It's simple, it's precise, but it's brittle. It breaks when data varies slightly, like John Smith versus Jade Smith. And by adding a graph layer, where we introduce transitivity and multi-hop connections. So the system can see that two records share a phone number, an address, or a device, and it connects them to one unified profile. Then probabilistic models use similarity scores, how two records are likely to represent the same person. But those traditional models look at each pair in isolation. And so what graph adds is context-aware scoring. It uses connected data like shared merchants, devices, or behavior to reduce false positive and increase accuracy. And then AI and machine learning is adaptive, but it often relies on flat features. So it sees data points, not relationships. With graph, we can add relational features like neighbors, paths, and communities, giving models richer explainable intelligence. And now the model not only predicts a match, but can also show why it's a match through clear relational evidence. So rather than replacing existing methods, graph strengthens them, adding context, scale, and explainability needed for modern AML and KYC. All right, so let's go a level deeper to understand how each of these approaches work. Deterministic matching is the foundation of entity resolution. It relies on rules and exact matches between two fields. Here, we're looking at three different data sources. Source one has social security and email. Source two has social security and phone. And source three has email, phone, and gender. And each of these contains partial information about the same person. So the graph model connects these sources using common keys: social security, email, and phone. And it creates relationships between them. You can see on the left that source one and source two share the same social security, so they're connected through the customer social security edge. Source three shares the same email, which creates another connection through customer email edge. And once these links are established, the graph can merge those connected records into a single unified customer entity. So deterministic matching gives us a solid foundation for identity resolution, but it's limited to exact field matches. And it struggles with typos, variations, and partial overlaps. And that's where probabilistic matching comes in. So real-world data is messy. People move, they change email addresses, they use multiple phone numbers, and data entry mistakes happen constantly. So deterministic rules can't just keep up with that kind of variability. And that's where probabilistic matching becomes essential. So rather than looking at exact matches, it measures how similar two records are. Think of comparing Barry Markham with Beryl Markham. They're not identical, but there's enough overlap to warrant a closer look. On this slide, you see isolated points, disconnected records with no known relationships yet. At this stage, we don't know whether any of them belong together. Probabilistic method analyze similarities across attributes like names, email, phone numbers, addresses, and even behavioral signals. And individually, these weak signals don't prove anything. But when you combine them, patterns start to emerge. And those patterns form clusters, groups of records that are likely to represent the same real-world individual. So here we see how probabilistic scoring works in practice. Each line represents a similarity score between two entities. For example, entity A and D have a 0.95 similarity score, meaning that they're almost certainly the same. But entity C and E only share a weaker 0.65 similarity score. And maybe they look alike, but not enough to conclude that they're the same. And different algorithms can be applied here. Jacquard similarity, cosine similarity, and others. each produce a score that tells us how close those records are. The key point is that probabilistic methods don't just say match or not no match. They let us quantify uncertainty, capturing the near misses and fuzzy matches that deterministic rule would ignore. Now, let's take those similarity scores, and we're going to start to cluster them together. And this is where we're seeing patterns emerge. On the left-hand side, we see a group of entities with very high similarity to one another. And on the right-hand side, another smaller cluster forms. So these clusters represent different individuals. Probabilistic methods catch subtle variations and connects records that are almost, but not exactly the same. Okay, so that's probabilistic matching. It brings flexibility, nuance to entity resolution. But to truly keep up with evolving data and fraud patterns, we need models that can learn and adapt over time. And that's where AI and machine learning take things to the next level. So let's look at AI-driven entity resolution, which combines graph context with machine learning. Now, this diagram shows the full AI-driven pipeline. The process starts with raw data, typically from multiple systems, customer databases, transactions, devices, and third-party sources. And the data is mapped to a graph schema where relationships like shared email, IP addresses, and phone numbers are represented as edges. Now, once we have that graph, we create features. These are representations of relationships. For example, features could include the number of shared connections, transaction frequency between accounts, or distance in the graph between two nodes. Now, these features are then used as inputs for our machine learning models. We train ML models like XGBoost or graph neural networks on these features. And unlike traditional models that look at one record at a time, GNN, for example, can learn from the structure of the graph itself, capturing how entities interact. Now, that allows the model to detect subtle multi-hop relationships that might indicate, for example, synthetic IDs or shared fraudulent behavior. Once trained, the models perform link prediction. It predicts the likelihood that two nodes represent the same real-world entity. So those predictions are then grouped into clusters, and this is what you see on the right-hand side. You see entity one, which has John Smith, which is formed between records A and B, and then record C, however, remains separate because the model identifies subtle differences. And this clustering process is continuous. As new data arrives, the model reevaluates and refines the entity graph in real time. So while deterministic and probabilistic methods depend on predefined rules or static threshold, AI-driven entity resolution learns and adapts. It scales with data growth, it detects emerging fraud patterns, and provides traceability for compliance. Okay, so we've walked through how AI-driven entity resolution work. Now let's talk about what it actually delivers. Traditional systems rely on rigid rule-based logic. They are brittle, they require constant tuning, and they still miss variations or evolving data patterns. AI-driven resolution, on the other hand, is fundamentally different. It learns from the context and relationships, not just predefined rules. And legacy tools compare one record at a time. Graph AI performs multi-hop reasoning across the network, uncovering indirect links that reveal hidden relationships like fraud rings. An AI-driven ER provides automated, explainable risk scoring, highlighting anomalies and giving traceability for regulators. And the outcome? Lower false positive, faster onboarding, and dramatically better customer experience. But the theory only goes so far. The real question is, what does this look like in action? So one of the best real-world example comes from Nubank, where entity resolution became the foundation of their fraud prevention breakthrough. Nubank was facing 72,000 fraud cases with new fraud patterns constantly emerging. Legacy predictive models struggled. They could only look at isolated attributes, which led to low precision, high false positive, and frustrated customers. With TigerGraph, the breakthrough came from resolving entities across accounts, devices, and transactions. And by connecting signals like shared phones, emails, or transaction behaviors, they could see the full context of a customer or fraud ring, not just individual records. That entity resolution foundation allowed their fraud models to run faster and more accurately. And the result, 3x more transaction screened per minute, and at the same time, a 3x reduction in false positives. Now, our next example comes from the digital identity verification space, where entity resolution is absolutely central. So the challenge here is twofold. First, enterprises face increasing threats from fraudsters exploiting digital channels. Second, identity verification processes are often manual and fragmented, leading to inefficiencies, higher risk, and poor user experience. And of course, KYC and AML compliance requires strong, adaptable solutions. By applying TigerGraph, this provider can connect and resolve identities across documents, devices, and accounts to deliver a unified, trusted view of each customer. And that means better fraud protection, smoother onboarding, and stronger compliance. And the results are striking. Up to 80% fraud reduction, 10 to 30% higher conversion rate, and 50 to 70% improvements in operational efficiency. Now, the key point is that entity resolution isn't just about meeting compliance and regulator expectations. It's also about creating frictionless, trustworthy experiences for customers. All right, so we've done a lot of slides now. Let's take a look at how entity resolution works in action. We're going to walk through a demo of what happens inside TigerGraph. We start by looking at the problem as it exists today, duplicate profiles, fragmented records, and then we'll walk through how TigerGraph improves precision, improves recall, and ultimately business outcomes. Okay, so here we start with an operational dashboard that shows customer records being processed. From the get-go, we see that all of the key metrics at the top are in red, and the root cause becomes clear. 5% of customer records are duplicates. Now, 5% doesn't sound major, right? But that duplication rate creates a massive downstream impact. Precision, which in this case is 72%, tells us how many flagged duplicates are truly matches. What a low precision rate means is that teams are chasing false positives that aren't actual matches. Recall, on the other hand, and in this case it's 68%, tells us how many real duplicates were successfully captured. Low recall is indicative of many missed duplicates, real risk slipping through the cracks. And so in this case, low precision and recall drive higher operational cost. They slow down investigation, and they provide inconsistent reporting. And it's not just a data problem, right? It's an operational problem. The ripple effects shows up in SLA performance with delayed approvals, missed SLA, and higher cost. So let's take a look under the hood at how entity resolution process works in TigerGraph. So here we're starting with our graph schema. Now, the schema defines how customer data connects, linking people, accounts, devices, and identifier like email, phone number, and address. At the center is the party vertex. This represents an individual. Now, each party connects key PII nodes like name, email, phone number, address, date of birth, ID, and even device details. And this structure allows us to spot shared identifiers across systems. So for example, two parties using the same phone number or address, which helps uncover hidden relationships and potential duplicates. Now, what's powerful here is that customer profiles can be updated continuously as new data comes in. So this is not just a static schema. This continues to evolve with new data coming in. So now let's take a look at how the data, how the query actually powers entity resolution. So this graph query, they use the schema that we just looked at to traverse relationships across millions of records. So it uncovers hidden matches that might not be visible through traditional database joins. And the workflow is driven by two core queries that we're going to take a look at. One is the match party entities. Now, this query identifies potential duplicates by comparing PII attributes and assigning match scores. And then the unify party entities query, which merges those duplicate records into a single unified entity once the confidence score passes a defined threshold. Now, together, these two queries handle a full life cycle, detecting, scoring, and consolidating entities into a in real time into a single source of truth across systems. So here we're looking at the match party entities query, and this is what actually identified records that represent the same person. So here's how it works. It compares party vertices across multiple PII attributes, so things like email, phone number, address, date of birth, and ID. And each of these attributes is given a weight, depending on how strong of an identity signal it is. So for example, email or government ID carries more weight than, say, address, which could be shared by multiple people. Now, the query then computes a similarity score between each paired entities. When that score meets or exceeds a defined threshold, a same as edge is created. And that edge links those records together as the same real-world entity. So once we run the query, we see the result. 531 duplicate records group into 178 clusters of matched entities. So now we'll run the unify party entities query to merge those clusters into a single record. So what this query does is it reads all of the same as edges that were created earlier, and it groups the connected records into what we call a connected component. So each representing one real-world person or organization. So for every component, the system then creates a unified record linking all of the contributing parties together while still preserving their individual traceability. So once the unification query completes, we get our final results. The system created 178 golden entities. And from here on, any new or duplicate data that comes in will automatically map to those unified profiles, maintaining a single source of truth across the systems. All right, now that both queries have been completed, let's return to our operational dashboard to see the business impact. Now we see that duplicate records have dropped from 5.1% to just 0.5%. That's an 8-fold improvement in data quality. Precision and recall are now both above 90%, meaning we're accurately identifying true matches and eliminating false positives. And data completeness has improved to 95%, showing we've successfully connected fragmented profiles across systems. Now, onboarding times are faster and more consistent with fewer manual reviews required. And SLA compliance has climbed back to 95%. Okay, so let's wrap up by looking at why Graph is such a powerful foundation for entity resolution. So first, Graph offers a natural representation of relationships and networks. Instead of trying to force connections into rows and columns, a graph directly links people, accounts, addresses, and devices, capturing how entities truly interact. Second, Graph enables real-time link traversal across multiple hops. You can trace shared identifiers like IPs or devices and instantly uncover hidden relationships that traditional databases simply miss. Third, they make multi-source data fusion simple. Whether it's structured data like transactions or unstructured data like documents, everything comes together into one unified view. And finally, graph databases support in-graph similarity scoring and ML integration, allowing deterministic, probabilistic, probabilistic and machine learning based matching to all run natively within the same environment. Okay, so now let's talk about why TigerGraph is the right platform for AI-driven entity resolution. So first, TigerGraph is designed for 10 plus hop traversal with a native parallel graph engine. That means that it can follow complex chains like phone, address, device, transaction across millions of records in real time, uncovering hidden links that other systems can't. Second, TigerGraph is the only graph database to offer massive scale and real-time performance. With distributed storage and compute, TigerGraph supports large-scale deduplication, watch list screening, and fraud detection, all happening in real time. Third, TigerGraph integrates natively with frameworks like PyTorch and graph neural networks. And finally, with GSQL, teams can define their own matching rules, adjusting weights, thresholds, and even performing incremental deduplication without reprocessing the entire data set. So TigerGraph doesn't replace deterministic, probabilistic, or ML-based method. It amplifies them. It brings them together, and it includes context, speed, and intelligence to deliver the highest accuracy possible at enterprise scale.